to go over today is permutations and combinations. I am going to ask you guys to put your phones away. If you guys were talking to me, I would not just sit on my phone and ignore you. So I want to make sure that you guys have these set up. These are the first two things that we covered in the statistics unit. So does anybody remember the difference between these two? And we'll say, whenever I gave you a situation, sometimes it was a permutation and sometimes it was a combination. What did we look for? All right, we looked for order. So in one of these, order matters, and one of them, order doesn't matter. Do you guys remember which one order matters in? The permutation is when order matters. So that's the first thing I want you guys. We're just going to make a little cheat sheet because tomorrow you guys will have a study guide. And I know that you guys, we did this in the packet, but I think if I have it just like simplified a little bit, it might be a little bit easier. So permutations is when order matters. Order matters. All right, so in combinations, order doesn't matter. All right, now with permutations, I'm going to switch this out in just a second. So with permutations, order matters. And so you are arranging objects. Sometimes you're arranging all of them. Sometimes you're only arranging a select group of them. So I'm going to say, I think the homework example that I gave you guys on your assignment for this, and I think we did something like this in notes. If I asked you how many different ways can you arrange 6 books on a bookshelf? Are we arranging all of the books or just some of the books? Yeah, if I just say how many ways can you arrange 6 books on a bookshelf, that would be just 6 factorial, which would be 6 times 5 times 4 times 3 times 2 times 1. So we would have 6 factorial there. Now, if I said you have 6 books on a bookshelf, selecting them one at a time, that means so like the order matters in how I'm picking them. How many ways could I pick? 4. On this is where I'm taking a few out of the group. I'm not arranging all of those, and so that had a formula with it. So when order matters and you are selecting a certain number, and so I just used N and K because those are just the common numbers that we use. Sometimes you also see R's. I think in the packet it had R's. In some textbooks it has K's. So if you are selecting objects there, we would do N factorial and then divide it by N minus K. So I just want to write a couple examples. All right, so the example here, I need a pen that works. There we go. All right, so the number of ways to arrange 6 books on a shelf. That means that we're arranging all of those. So we would just do 6 factorial. So do you guys, I didn't have you guys grab a calculator, so just quickly, you guys have phones. If we want to do 6 factorial, we would actually say 6 times 5 times 4 times 3 times 2 times 1, which you can do dots however you would like to do that. But what is 6 factorial? I believe so. Is that just a memorization? Good. It is 720. So if you're arranging all of them, it's just that number and then factorial. Now, if you're taking a certain group out of them, so like an example here would be how many ways to pick, oh, let's go 4 books out of 6 books on a shelf. And we're going to pick one at a time. And on this one, seeing the words one at a time should be the red flag that order matters on this one. So we are arranging we're picking one at a time. So in this case, our total number is 6, but we're doing a permutation and picking 4. So we're picking one at a time, so order does matter. So what am I going to put on the numerator of my formula? It says n factorial. N is the total number of objects. So how many books do we have to pick from? 6 factorial. And then the bottom is 6 minus 4 factorial, which is just 2 factorial. And you guys actually did a really good job whenever I told you if it was a permutation or a combination doing the formulas. It was more in the problems deciding if it was a permutation or a combination when you guys started making the mistakes. So 6 factorial means we're going to multiply 6 all the way down to 1. And then 2 factorial is just 2 times 1. What do we have on top and bottom that we could cancel? The 2 and the 1. So our 6 factorial goes from 6 all the way to 1. The 2 factorial is just 2 and 1, but we have a 2 times 1 on top and bottom. So then you guys can multiply 6 times 5 times 4 times 3. I'm going to say, what do we got? 360. Now, the next thing I want to talk about is when order doesn't matter. And those are combinations. So we are still picking. So if you're still picking a certain number from a total number of objects, the formula is slightly different because whenever you have combinations and order doesn't matter, all right, I'm just going to do like a letter combination really quick just to justify or to like explain this. All right, so if I told you to arrange 3 letters in the alphabet, but order didn't matter, or to pick 3 letters from the alphabet, but order didn't matter. All right, let's say Luke says ABC, but let's say Mia says CAB. Is that the same group of letters? All right, so when order doesn't matter, it takes out like whenever you have the same combination of letters, you don't want to count those twice in the number of ways that you can arrange it. So it makes that number a lot smaller. So that's why you have to divide it by a little bit more. That extra k factorial in the bottom is going to take out those combinations that repeat that are the same. So that way you're not counting things twice. So if I wanted to do something like this where, all right, so let's just say ways to select. let's just do 4 books out of 6 all at once. All right, so if I'm selecting 4 books out of 6 all at once, does order matter? I'm just going and grabbing 4. Did I pick them in a certain order, or did I just, order doesn't matter here. I'm picking them all at once. So this would be a combination. And so here, I would write 6C4 for a combination. So my numerator is always going to be that number factorial, the total factorial. But in this case, k is 4. So k is 4 factorial. Now what's 6 minus 4? 2 factorial. So the number that you're picking is here, and then the 2 numbers on the bottom always add up to that top number. So 4 and 2, so our 6 factorial, if I expand this, it's 6 all the way down to 1. All right, and then I've got 4 factorial and a 2 factorial. So I've got my 6 factorial on top, and then I have my 4 and my 2 factorial on the bottom. Do you guys see anything that's the same on top and bottom I can get rid of? You know, say, do both of them have a 4, 3, 2, 1? All right, so 4, 3, 2, 1 can get marked out here. 4, 3, 2, 1 can get marked out here. So tell me what's left in the numerator. I'm just left with 6 times 5. What is that? 30. And then on the bottom, I'm left with 2 times 1, which is 2. What's 30 divided by 2? 15. So if you can see, when order is specific, there's a lot more ways. When order's not specific and different combinations are counted as the same thing, it definitely takes out the number of possibilities. So our combinations are going to go way down. All right, so do you guys have all of these written down as a cheat sheet? Why did you not write this down? I told you you're making a cheat sheet. You know, say I can zoom in a little bit. No, because if I zoom in anymore, then you can't read everything. I don't know if I can lift this up. All right, so I can't zoom in anymore. You know, say you maybe don't have the examples written down, but at least have the bold written down. Because I'm getting ready to put examples up, and I want you guys to have the formulas. Luke, let me know when you're ready.
You can do all that.
Okay. All right. So I've got a few questions, and we're going to decide first, does order matter or doesn't matter? All right, a person would like to run 4 errands but only has time for 2. How many pairs of errands could be tried? All right, so it doesn't matter. So you guys tell me right now, is that a permutation or a combination? All right, so this is a combination. Very good. Order doesn't matter. We don't care which 2. We need to get something done. So you have 4, just do 2 of them. So this is a combination. So if I want to write this, am I going to write 4P2 or 4C2? C2 for combination. So it's 4 and it's a combination and I'm picking 2. So if we go to the combination formula, what goes in the numerator? And I'll say, what number goes on top? All right, 4 factorial. Don't forget that factorial. That makes a huge difference. All right, now what goes on the bottom? So my formula tells me to do k factorial and then n minus k factorial. So my k in this case, my n is the 4 and my k is the 2. So I'm going to do 2 factorial, but what is 4 minus 2? For the second factorial, it's also a 2, and does 2 plus 2 equal 4? Those 2 on the bottom will always equal the top number. So let's expand this. All right, so we got 4 times 3 times 2 times 1. And then on the bottom, I have my first 2 factorial is 2 times 1. And then my second factorial is 2 times 1. What can I get rid of? 2 and a 1. All right, so I'm left on top. 4 times 3 is 12. And the bottom is 2, so what's 12 divided by 2? All right, we've got 6 ways to rearrange those. Yeah. Sorry, it didn't look that bad when class first started, but sun's starting to move. I promise I'm not trying to blind you all.
Thanks, Scooter. Happy steps.
All right, do you guys have any questions on that one? So the first thing you have to ask yourself on every question is, does order matter or not? And then once you determine that, then you go straight to whatever formula you are doing. So let's look at this second question. There are 6 people who want to use an elevator, and there's only room for 4. How many ways can 6 people try to fill this elevator if they enter one at a time? All right, order matters, so what does that mean? Permutation or combination?
Permutation.
All right, this is a permutation. What made you decide that order mattered?
It's asking how many ways 6 people can fit in the elevator.
But what words made you know the order mattered? One at a time. That was the key. One at a time. All right, so this would be a 6. Permutation is a P4. So we got an N and we've got a K. Now I'll say we've actually kind of done these numbers already. All right, what goes in my numerator? 6 factorial. Now what goes in the denominator? Are you sure about that? Look at the formula. What goes in the denominator? 6 minus 4 factorial, or 2 factorial. I heard both things. So whenever you go to this, you guys will be given the formulas. So if you know it's a permutation, you know that the total number goes on top, and then on bottom, you're taking the 6 minus the 4. So I actually don't care if you write 6 minus 4 or if you just go straight to 2 factorial. I'm okay with that as well. All right, and we did this one already. Do you guys remember what we got when we took 6 times 5 times 4 times 3? 360. All right, I want you guys to try this next one on your own. How many ways can I select 2 cards from a set of 52? I'm just picking 2 cards. All right, you try it. You try it on your own. Decide if it's a permutation or a combination, and then go with the formula. We will go over it, but I want to give you guys some time to try it by yourself first. And I will tell you, your answer is a 4-digit number. It should be a 4-digit number for your final answer. What?
What do you push again to make it? What's the I one?
The exclamation point. So that's a big number. Okay, so this is a really big number, but if you I obviously don't expect you to write 52 all the way down to 1, but kind of shorthand it. So sometimes the calculator gives you too big of numbers. It's, you know, did you see on the last examples how we expanded it and then marked out things that we saw that were the same?
Yeah.
Then there's less numbers to multiply, so it's not going to like max out your calculator. Because 52 factorial, your calculator will like put it in scientific notation.
Then you put like 2i and then you put like on the bottom you put it's like 52i over 2i and then 50i.
They're not I's.
Or, but,
What do we call those?
i's. Or
No.
exclamation mark.
But what, in math, what do we call those exclamation points? Starts with an F.
Factorial.
There we go. All right, so Kobe seems to think the order doesn't matter on this one. What do you guys think? Well, if I set out 52 cards and I say pick 2,
No, it don't matter.
no, order doesn't matter. So this is a combination. All right, so you should be doing 52 and a combination, and we're picking 2. All right, so in a combination, 52 factorial goes on top. 52 factorial goes on top no matter what. The total's always on top. Now on the bottom, are we going to have 1 number or 2 numbers here? 2. The first one is 2 factorial, but what's my second number? 50, because 2 plus 50 gives me 52. All right, now if you guys think about this, the biggest number on the bottom is 50, right? So if you think about 52 factorial, do you guys agree that's 52 times 51 times 50 times 49? And then I'm not going to write all of those, but would you guys agree that would go all the way to 1?
Yeah.
All right, now 2 factorial is just 2 times 1, right? Now what's 50 factorial? 50 times 49 all the way down to 1, right? What do you see the same on top and bottom? 50 to 1. So, Luke, do you see where this really knocked out a ton of numbers?
Yeah.
Because both the top and the bottom were multiplying 50 to 1, so you don't need to list those both. So we only have these two numbers on the top. So what is 52 times 51? 2,652. And then the bottom, you now just have 2 times 1. So divide that number by 2. 1,326 ways. All right, so I want you guys to think about this. If I gave you guys a 52 question multiple choice test, 52 questions, and I said everybody in the class only missed 2. What do you guys think I would, if everybody in the class missed 2? Why would you think, why would I suspect something there?
Cheating.
All right, why would I suspect cheating? If everybody missed 2 and there's 1,326 ways that test could be answered, and everybody answered it the same way, do you think I'd maybe have a reason to be a little skeptical? Maybe just a little bit? Not that bad, but yeah.
How mad do you get?
Huh?
How mad do you get when people cheat?
Needless to say, that group had to all come in, because I don't know if you guys know that like Canvas timestamps everything. And so I just ran a report of everybody's quizzes, and the ones that were all identical, it sorted them and it gave me names, and then I timestamped it so I knew who started it and then who shared it and who copied off of who. So I let them come in and retake it for 50%. Well, it's not, the ones that cheated bombed it, so it didn't really matter anyways, but
They cheated and failed it? Or they cheated?
well, the one that they cheated on didn't count, but when they had to come in and take it on their own, they bombed it. But the one person that like actually knew what they were doing got an A on it, but really got a C because they got half credit. So don't cheat. Everybody, you get caught.
You really do.
Huh?
I said you really do.
You really do?
Remember last year in Borden's class?
Oh, yeah, I remember.
We all cheated. But,
Don't cheat. Don't tell me these things.
Hey, we didn't do it after that.
yeah.
Cheated.
Oh,